of the plenary. So thanks everyone for coming along. I'll just go to full screen. This session, we will be exploring the FAIR requirements for federated infrastructures in the life sciences and beyond. So this is actually the second time we've held this session. We held it last week at a different time of day. So today we are going to have a short intro by me, and we'll have a bit of an icebreaker. Then we're going to hear about, I guess, two promising approaches for federating infrastructures in life science. And one of those is an approach where we use a standards-based approach, GA4GH. So we're going to hear from Taku Musarua on what's going on in Africa, where they're implementing GA4GH standards for federated data analysis. And then we'll hear from Björn Grüning from Freiburg in Germany around the building of a Galaxy platform and how that enables federation of infrastructures as well. Then we're going to have three fairly short flash talks from Rob Hooft in the Netherlands, Sven Gundersen from Norway, and Rory McNeil, who's in Edinburgh, but we're talking to us about the New England Research Cloud. So hopefully we'll get to the end with plenty of time for discussion, and we're really hoping that we'll be able to use that time to identify synergies and opportunities for further collaboration with other groups leading up to future RDA plenaries. So if you're new to the RDA, just I guess a heads up that interest groups really are intended to serve as an ongoing platform for communication, discussion, and coordination amongst individuals, both within and also outside the RDA. And obviously we have shared interests. This particular interest group, the Life Science Data Infrastructures Infrastructure Group, we formed it just a couple of years ago, and that was to act as a bridge between the operators of life science data infrastructures from anywhere in the world and forming as a bridge to relevant RDA groups. The current chairs are listed here. So we have Nikki in South Africa, Susan and Alicia from North America, Volmar's here representing Europe, is based in Sweden, and myself, I'm based in Australia. So the group currently has about 150 members, and we've had up to 60 attendees at these plenary sessions. So just a very brief whirlwind tour of what we've done at the previous three plenaries. In June 2022, we introduced ourselves to the RDA, and the discussion that we had there, I guess, acknowledge that researchers, and it's not necessarily specific to life science researchers, they never really just use one data infrastructure in a research project. Throughout a research, life cycle, they'll use multiple infrastructures. And in that session, it was suggested that an initial common topic of interest was to think about how can life science data infrastructures themselves, but also the digital assets that are associated with those infrastructures, be more fair. So prior to the next plenary, the interest group chairs, we went away and we surveyed the operators of 13 infrastructures around the world who are listed here. And really what we wanted to get an idea of was, from the operators of those infrastructures, how fair did they believe, how mature was the fairness aspects of their resources and the digital assets they managed within them. So this table here is showing the results of that self-assessment. So the different stages of the life cycle are shown here as rows, and the different resources as columns. You can see here that some groups thought they were, very mature across all of these aspects. Others a bit of a mixed bag. So at that March session, we presented the results of that survey in quite a bit of detail, but we also heard directly from the operators of 6 life science infrastructures who are listed here for their reflections. And I guess where we came to from that session was definitely a acknowledgement that none of the life science data infrastructures we identified to that point support all the stages around the life cycle, the research data life cycle. Most of them support processes that are only associated with a few stages of the life cycle, and the digital assets have to be handed off to another infrastructure for the next stage of that life cycle. So researchers are often using multiple data infrastructure to support their research, and they really need to get the data or the digital assets moving around that life cycle. That handover is very non-standardized. It's often done manually. A researcher has to do it themselves. Sometimes it can be supported by the use of an API. And generally, most probably not, metadata does not accompany that digital asset. So in October, I guess we came together to talk about it a bit more. And one of the things we thought may be useful is perhaps we can work on some guidelines to be produced for the operators of any life science data infrastructure globally that would help make the digital assets housed in them more fair, which would enable a better handover of those digital assets to the next infrastructures in the life cycle. So we had a bit of a brainstorming session of what the guidelines may contain. So there's many things here. I'm not going to go through it in detail now. We'll have a link to the slides, but I don't think there's any surprises. You can see here that there's concepts around using persistent IDs, ensuring that metadata is standardized, having appropriate licenses, having standardized formats, so on and so forth. Okay, so coming to today's session, what we really wanted to do is, I guess, showcase some examples of successful and promising approaches for federating infrastructures. And as I said, we'll be hearing about those today. And we hope that what we hear about today will inform ongoing discussion for the group and really work towards identifying future work and collaborations across the RDA for this interest group. Okay, so here is a link to the collaborative session notes. We'll put the link in the chat if it's not already there. But if you can scan that or go to that URL and note your name, that would be excellent. And just to keep things moving along, we're going to have a bit of an icebreaker. So over to you, Volmar.
All right, so here we go. This is a Mentimeter. There should be a link now in the meeting chat. So if you click the final link there, the icebreaker poll, you will be able to sign in to this vote. You can click the thumbs up, or you can just proceed to the next question, which is just taking the polls of the participants here. So where are we from? Where are we joining from today? And you can just add your country or city or both, continent if you please as well. So we have some people from Norway, Germany, Europe. The time is Euro friendly, so it's not strange. EMEA, I'm not sure where that is. If someone wants to share, please do. Cork, Sweden, of course. And that's where I am located. Jeff is connecting from Australia, and we have also participants from South Africa. So nice to see. And I will also share a link, or there is a link in the shared meeting notes where you can see this as it's being updated. This is an overview of how we identify ourselves in relation to life science data infrastructures. So are we primarily users of it, or the other way around on this graph? Are you someone giving direction to what the life science data infrastructures should do? And it's interesting to see there's, I think, a bit of a change in the distribution compared to the last session. But we did have a lot of people staffing its services last time as well. We might, and also supporting users of it. So it's going to be interesting to compare after this session. And then we had a question here on your expectations from joining this session and what you would like to kind of have as the takeaway messages for going away from here. So learning more about Galaxy, it's on the agenda. So that's definitely going to be something you can take away from here. Knowledge and experience. It's also going to be in the talks and the discussions as well. We're looking forward for you to share your experiences and suggest things to look into as well. life sciences metadata. I think some of that will probably show up in the presentations as well. And it's an important topic, of course. Disciplinary repositories, I'm not sure if that's going to be covered, but it might be in some of the examples. It's an important thing nonetheless. And I think we can keep this up for just a few seconds longer. I mean, if you take your time and answer the poll later on, we will go back to this. So it's not a wasted effort to complete the question, even if we close down this session and proceed to the next speaker. So thanks a lot. I think we can serve some of this, and following up after this session, we can probably address some more of these, and we would encourage you to engage with us in the interest group. And with that, I think it's time to leave the room to the next speaker.
Thanks, Volmar. And over to Taku Musarua, who is joining us from Cape Town today in South Africa. He's going to fill us in on work they are doing in Africa to implement GA4GH standards for federated data analysis in Africa.
Okay, thank you. Hello, everyone. So my name is Taku Musarua. I'm from the University of Cape Town. So I work with Professor Nikki Mauda on the Elwazi group, on the Elwazi project. So I'm just going to give an introduction to the Elwazi project and the different partners that are involved within the project and our service users as well. And then I'll go a bit into the Elwazi pilot platform that we are developing. So what it does is that it implements the FAIR principles within our infrastructure for different users we have. Right. Okay, so Elwazi is an open data science platform that was brought about because of a need for the different researchers across Africa. So basically, the platform is to ensure that data is accessible, is easily findable, and users can select tools and workflows and probably run analysis on different computing environments. So the computing environments can range from cloud computing and also locally available computing settings. All right, so this is all supposed to be done through a user interface or a workspace that is, probably specific to each and every project. But at least Elwazi, in this case, it sort of like brings about a central point for where all these resources can be shared. All right, so the main three components are we have the infrastructure, we have the data, and then the tools. So the platform itself makes use of Terra and then Gen 3 implementations, biosphere concepts, and we also implement the GA4GH standards within the tool itself. All right, so what Elwazi really aims to do is to make sure that the different data sets for the different projects are easily accessible, like I mentioned earlier, and we can integrate these different data types because most of the times you realize that people have like varying data and they're probably in different formats and they have different policies as well when it comes to accessing this data. Right. All right. So yes, like I mentioned earlier on, is that we want to develop an African data science platform with associated resources to support the data science and health discovery in Africa. All right. So this is the current setting that we have for the researchers. Of course, this is going to change once we fully implement the pilot platform that we're working on. Right. So what we have here is that people use these different platforms, Terra with Gen 3 and Docstore, but they're using them in their own way. It's not really sort of like standardized for all the researchers. So sharing data and sort of like collaborating within researchers is a bit, difficult, so to speak. Right. Yeah, and these are the other applications which are currently being used. All right. So this is the overview of the Elwazi infrastructure or the Elwazi project itself, where we have a gateway here, right? And then we will then have a workspace for the users where they search their data, retrieve databases, and select respective tools for their analysis. And then from there, they should be able to access, like the data will be stored maybe in a desk repository, data registry services, and select tools, maybe from Docstore using the test APIs, and also submit their workflows to compute through the WES APIs. And this, again, is going to be supported by the implementation of GA4GH standards, like I mentioned earlier on. right? And then from there, this data, again, it also links to the catalog, to the data catalog. So the data catalog basically has all the information for the different projects, so that the data is easily, browsed from other projects, and you can request for access. Let's say if there were certain policies which limit you to access data from different countries and the likes. Oh, and of course, there is also an opportunity to make sure that we expand the project once it's completed, to make sure that we try and collaborate with other researchers from all around the world. Okay, so what we want to work towards overall after we finish the project, or maybe we deliver the most expected requirements for the project, make sure that the user can sign into your workspace. You search from the catalog for data sets. And then you get a list of your data sets and the location and access information and access rights, like access rights to the data from the data registry. And then you fetch the data and you select your computing tools, or the workflows, let's say from Docstore. And then you choose a computer infrastructure that you need or that you have for your local research hubs. All right, so the partners we have at Elwazi, they are spread across the world, most of them in the US, and a lot of them again in Africa. So we have some here in South Africa, like you see there, we have Professor Mauda and Oliveira from Stellenbosch University, and Hazelhurst from Wits in Joburg. And the other ones are from Uganda, Mali, and Kenya as well. And there's also, some from Mauritius here. So basically there are 7 partners from the H3A Bionet. So these are the ones which are in Africa, and 3 from the USA, and then 1 from the UK. Okay, so the projects that we support are part of the DSI Africa Data Science in Africa Research Hubs. So these are the main ones. These are the main research hubs that are there, but they also have like different projects within themselves. And as you can see from my slides here, these projects, their research is mostly in different fields, really, because some are dealing with antimicrobial resistance, and some are in health, using health data, health research, just trying to see how the climate is impacting health in Africa. Some are into imagery data, they take radiography images and try and apply machine learning to them. So basically just sharing data within the projects themselves or within the research hubs is more of a hassle, if I would say that. It's more of a hassle because you have people who are in different locations with data of different formats. And the way for standardizing that is really a bit difficult. So that's where we then come in and try to say, okay, with these GA4GH standards that are available and the FAIR principles, how best can we make sure that research and collaboration is easy for the different projects? Okay, so the data diversity within these projects, I just try to summarize some of them from what I could pick from their different websites. Like as you can see, camera here, they have clinical and phenotypic genomic data, and some have biomedical, environmental, geospatial data. So the goal again is to say, let's say maybe for another project with genomic data and we have people with geospatial data and maybe weather information, how best can they collaborate? How best can they link the 2 data sets? And what platform can they use to say, okay, we want to see how the weather is impacting, or maybe how is it related to maybe the genetic makeup of people from a specific location. So now this is where the 2 will then come in to try and leverage and solve these kind of problems, right? And like I mentioned earlier on again, this diversity is one of the main reasons why we needed this to embark on this project, to make sure that we come up with these solutions. And again, the researchers, like I mentioned, are spread across Africa. Like you can, for example, like I just put this example for the MATSRE project, where we have researchers in Uganda, Kenya, Ghana, and within Kenya alone, again, they are spread across the whole country. So these people are going to have like different repositories where they store their data. They're going to have different policies, maybe by institution. And again, researchers, we have different preferences. Let's say if you want to analyze your data, some are going to be like, okay, we work strictly in Python. Some will be like, we work with R. But if you then want to collaborate, you have to sort of like find the common ground, like if you're going to use different computing resources as well. But if you're going to use your data, we have to make sure that we still get the same results. So this is where we try and come in and solve this kind of problem. So to better understand the GA4GH standards, what we did last year, sometime in August, was that we invited Brian O'Connor and the team from GA4GH just to take us through the GA4GH starter kits and how best we can implement them. and how, and also getting examples from others who have used them before. I remember we had Miro, and he also gave a demonstration on DNA stack on how they apply Data Connect for searching data, right? So basically the workshop was more aligned on implementing the starter kits themselves. And from this workshop here, we managed to start on a pilot project, right, where we sort of like included all the different standards that are there, more specifically the ones which were most relevant to our infrastructure. So we implemented the data repository service, Data Connect and WES, right, as a start. And from this platform project, that's when we got to where we are now. So I'm just going to sort of like show the main goal of the Elwazi pilot platform project. So the main idea was that it was a proof of concept for data sharing and compute across Africa using these GA4GX standards. So we started using the 1000 genome data, right? We selected a bunch of CREM files, and we selected the ACE regions. So the ACE regions are Africa Center of Excellency. The other location is in Mali, and the other one is in Uganda, right? So that's where we made sure that we set up an infrastructure there, a compute infrastructure and data storage in Mali and also in Uganda. So in Uganda, we had two sites, ACE Lab in Uganda, in Uganda Virology Institute, and another one here in Ilifu in South Africa. Right, so we divided our data into 4 batches, right? And then we put them in different disk servers. And we had a central location here in South Africa, right, on the Ilifu node or the Ilifu infrastructure. So on the Ilifu infrastructure, we had the Data Connect server, right, where we stored all the data or information for the different CREM files, and also including the disk IDs for those CREM files, so that a user should be able to query from the Data Connect and select the disk IDs and possibly then send them to a WES endpoint for compute. All right. And overall, after you do that, the main idea was, it was just a basic process of performing some flex stats on the CREM files. And then after you perform your statistical computations, you then take the flex stats to a one central node, and then you combine into a multi-QC report. All right, so I'm just going to go into each and every step of what I tried to summarize here, just to get a bit of an understanding of how the whole project works. Right, so like I mentioned earlier on, you start with your Data Connect server here, right? So this Data Connect server is selected in is located on Ilifu here in South Africa. So what Data Connect does is that it supports federated search for different kinds of data, right? So a user can access any data of choice. The overall goal is to make sure that all the different projects or research apps that we have, different DSI research apps, will then input their data in there, or at least we'll collect their data through a platform after we sort of like harmonize their data, and then we include it in there, including the disk IDs, which can then be used to refer to the exact location of the data. So from there you can browse the data. But what we used here, for these CREM files, we had the population, we had the sex, in the location, the country of origin for the data. That's what we currently have in the Data Connect server, right? So a user will query the data of interest, right? And what we have here in the orchestrator, what the user is currently accessing is a Python notebook, right? So when you're querying your Data Connect server, you are writing your SQL query to select the kind of data you need based on on what kind of research you want or what kind of populations you need. And then from there, you then get a list of disk IDs, right? And probably visa IDs as well. But this is yet to be added within the Data Connect. It's something that we just figure out that it's probably easy to maintain it that way. But in the end, again, like I mentioned, that we have a notebook here. We're also developing a dashboard, which will then replace this to make sure that a user can only do this through a user interface. Because remember, some of the researchers we have, maybe people are geneticists or they're biologists. So their understanding of working with query languages or programming languages is a bit limited. So we're trying to make sure that we make it as easy for the users as possible. So this is the first step for querying data, right? And then after you query data, another addition we managed to do was to include the test to register service within the pilot platform. So what the user does is that you go to Docstore and then you browse available workflows to say, okay, for the data that I have or for the kind of research that I want to perform, what tools are there, what standardized workflows have been posted by other researchers as well. Because remember, again, we want to make sure that this work is reproducible. So a user will then browse the different workflows in here. Maybe you have your Nextflow workflows, or you have Wedo workflows, and then you receive a test ID, right? And then this will be retained again in the orchestrator, right? And then from there, the user will then get their user ID and visa IDs for the respective data sets that they have obtained. So basically, what the passport broker does is that it provides a standard way to express data access rights. Right? So it ensures that data is limited to only people who actually have rights to access this data. So like I mentioned earlier on, we have different countries with policies where they can say, okay, our data cannot leave this country, or it can only be computed within our infrastructures. Or maybe if you want to share data with specific research hubs, then you have to ensure that whoever is going to access the data has been given access to that data by the proper authorities or by the owners of the data, right? So from here, the user from the orchestrator will submit their user ID and a visa ID, and then this visa ID now it is linked to the DES IDs that one would have obtained, right? So if you get data and you notice that maybe you need access to it, then you post the user ID and the visa ID, and then you get your passport token. All right. And with the passport token now and the DES IDs again, you then query the data repository service, and then you get the DES object location. So what we had in this case was that when you query this, you get the orchestrator will get all the information about any data object that is stored within the DES API, right? And then from there, you then select only the specific location of the data. So sometimes you get, depending with how you want to process the data, you can either get a streaming URL or you can get the absolute path to the data set itself. So normally we ended up using the absolute path if the data is within the same location as the computing node, right? Or if you are in a different location, let's say you're in Mali and you want to access a data file that is here in South Africa, rather than copying it from South Africa to Mali, which might take much more time or would be, expensive computation-wise, you'd rather just stream the data set from where it is. Okay. So from there, you then submit your data sets or your DES locations and the test ID to a WES endpoint, right? So what the WES endpoint would then do is that when you submit this data locations and then the test IDs, so the WES server itself, right, will then query the Docstore test API using that the test ID, and then it will then get the actual workflow. And then this workflow is then stored locally just in case if you want to reuse it again. But if another version exists, it will still query and get the latest version or the version that you specify from your test ID, because this test ID also includes the version of the workflow itself, just to make sure that you maintain consistency with your workflows. And then from the WES endpoint here, it then submits your job to compute node. And then once the computation is completed, you then get a location of the output that you need. So within our orchestrator, we ensure that when you get your output here, we route it back to a DES server, right? Because we wanted to avoid a case where you have to share like absolute URLs, but rather than have it in a standardized manner. So your output will then be stored in the DES server, right? So from here, so this is like all the combined services for the pilot platform, right? Like I mentioned earlier on, after you perform all these tasks here, and once you get your output location, then that DES ID again for the final step of combining all the different outputs. So this was the final step now, where you say you're going to perform your multi-QC output. Your multi-QC consolidation rather. So you then submit your DES IDs and the test IDs to the WES server again. So but now this DES server, it's a bit specific to the user themselves. So this one would be, let's say, within the same node or maybe closest to the person who is performing the processes. So like I mentioned, if you're sitting here in South Africa, this would be this WES endpoint would be here in South Africa, so that we make sure that you don't try and move data around and you can only get your results from where you are sitting. All right, so yeah, so basically this is the main picture of Elwazi project. All right, so the current state of our project is we managed to replace the waste data kit with WasteKit. Our understanding was that it's near ready to a production ready product, and since it was open source as we were advised, it would be easy for us to add other features within this API as well. Like we've managed to add a desk resolver within it. We couldn't note it like initially. So what we then just do is that when we submit the desk IDs to WasteKit, to WasteKit, it then resolves that object. Another feature we want to add in there is to make sure that when we try to do the desk resolution here, we also want to add the passport tokens in there. So that's another step again we want to include here of integrating passports within the WasteKit API. And also the need for including passports is that we noticed that when you submit your workflows to WasteKit, there is no really restriction to say what kind of code are you going to pick in your workflow. So for instance, let's say if you have your Nextflow script, you can have a section where you can put your Python code. It can be malicious code, and there's really no way of telling what this code is going to do. Is it going to be limited to maybe bioinformatics computations or whatever analysis a user needs to specify? There's really no way of knowing that. So we're trying to ensure that we authenticate a user if they're accessing compute resources. How much of the computing resources can they access? So we're trying to make sure that we implement that from here and make sure that they are authorized and authenticated before they submit any jobs. Yeah. Right, and we're also implementing now the reference panel imputation service, right, within the pilot project. So this is going to sort of maybe not replace the FlexStat computations first, because at least that's a proof of concept that we saw that it actually works to some extent. So, but this one now, it's something that is actually being used by the researchers. So we're currently working on this, the reference panel. So it's going to happen in a federated manner, such that we have different reference panels in different locations. Right now, we're going to set up another one in Mali and the other one in Uganda, also in one here in South Africa, right? And when a user submits maybe their VCF files for imputation, they then get the output from those different locations and then do the combination of all the reference files at one location. And we're also exploring other GA4GH standards to include, like I noticed from the Connect session last time, that there are cases where we might need to use script4GH to ensure that whatever scripts we have or whatever workflows we get from maybe Docstore, they're actually encrypted to make sure that no other tampering can happen to them. And in addition to this, like I mentioned, we want to replace the orchestrator. So we're also developing a dashboard for users to then access the platform through. All right, yeah, so these are the future plans for the project, right? Like I mentioned, we have just started replacing some of the starter kits. And for the DES API, we're hoping to use Gen 3 because I think there's a production ready version or an implementation of DES on Gen 3. So we'll then replace the DES API with that. And also there are also passports within Gen 3 as well. So we will be able to use that. And for Data Connect, there is a possibility of then using DNA stack instead of the current setting that we have where we're using the APIs. All right, yeah, so there's also a demo on this link here. I think I'll just share this slides after the presentation so that if people want to just look at it, maybe put comments on it. Yeah, I would love to hear what you think about what we have done so far. Yeah, so yeah, maybe these are the people who are mostly involved within this project, and they've given us compute services. Like I mentioned, in Mali and Uganda, they've given us nodes where we can set up for our tests. And the infrastructure group here at Elwazi, they're really supportive, and the GA4GH community as well. All right, thank you. I don't know if we're going to have questions now or maybe later.
If people have a quick question now, that would be great. Thank you, by the way, that was excellent. There's a lot happening there, and I think very much related to, you know, the work that many groups are doing around the country, around the world, to try and get federated human genomic data analysis underway. I guess I just had a quick question, and it was around, I think at the end, so you mentioned Terra at the beginning, and I guess these sort of very much cloud-based analysis platforms, but I think just throughout the talk, you were also talking about having local compute. So is the aim, I guess, in the long run, to have a flexible system that would enable whoever to do their analysis wherever they, I guess, had access to that compute.
Yes. Generally, that's the idea. So what we'll then do with the platform is that when you access it, you should be able to then access like computing, like you're mentioning, maybe from Terra or I don't know, AWS, all these other different services here that I listed down here. So yeah, overall, that's the main idea, to make sure that it's as flexible as possible, you know, for the users.
Thank you. I think we might move on. Questions, if there are questions, please put them into the chat. Just because of the time, I think we'll now move on to Björn. Thanks again, Taku.
Great, thank you.
Hey everyone, can you see the slides?
Perfect, thank you.
Awesome. Yeah, thanks for the invitation. I will talk about fair data analysis for the life science and beyond, using a platform called Galaxy. Short introduction, this is a project that started already in 2005, so we are nearly done and celebrating our 20 years anniversary. It's an open source framework, so every component that I will briefly show you is of course open source. And it's a lot about accessing, sharing data, tools, workflows, and infrastructure in general. We know about 130 public instances, so that means you can go there and create an account. And at least on the European and on the Australian and on the American Galaxy server, we are now deploying more than 3,000 different tools. And this is ranging from AlphaFold to biomedical data analysis tools, but also things like Jupyter Notebooks or RStudio. The 3 continental Galaxy servers that we deploy, so the European one, the American one, and the Australian one, have together more than 300,000 registered users at the moment. And this is just growing. It's a little bit hard to talk about Galaxy in just 20 minutes because Galaxy does really mean different things to different user communities. Yeah, if a scientist looks at Galaxy, it's a complete different beast than when you are a service provider and actually want to give access to your compute resources or to your storage resources with Galaxy. Or if you're running a mass training event, or if you are an educator and you use Galaxy as a training platform, it's also a complete different beast. If you are interested in different kinds of aspects, please let me know. I will concentrate today more on the abstraction layers, and in particular about a distributed and federated storage. Just to conclude the introduction, so many people probably that have dealt with Galaxy know that there is a front end and a website that you can use where you can create workflows and tools and so on. But Galaxy is actually much more. It's actually a backend, right, with over 500 API endpoints. And everything that you can do, obviously, with the web frontend, you can also do programmatically via the command line. And this includes running tools like AlphaFold, completely automatized, but also composing, scheduling, rescheduling workflows, doing the entire user management. So as I said, Galaxy can be deployed as a multi-user environment. So if you need to manage hundreds of thousands of users on the platform, you probably also want to do that programmatically. Or the entire data management of those users that I will go into detail in my next slides. If we talk about metadata and annotation, this framework and all the tools that are there are annotated with schema.org, with SPDX, so that's licensing information, and ontologies. So you can actually programmatically query tools, data sets, and so on. We do support and we work together with GA4GH. We do support the TRS and the DRS standards, as you have heard in the last talk. Galaxy is also deploying kind of a pulsar server that is a TES endpoint of the GA4GH standards to exchange data between Galaxy servers, but also consume data from other TRS endpoints or submit jobs to other TES endpoints. And I guess the rest I will cover in my next slides. Conceptually, and also from the technical standpoint, the Galaxy framework is very much about abstraction layers. So no matter what compute resources you have, you can configure Galaxy to actually use them. If it's cloud computing, if it's HPC computing, it doesn't matter. It's just a plug-in into Galaxy, and then Galaxy can schedule jobs. And the same goes for also object stores. If you have a POSIX object store, an S3 or an Azure blob, you can configure Galaxy to consume that, and I will show you that later. And the same goes actually for data imports, exports, for authentication. We have heard about passports, OIDC providers. So all of that can be plugged into Galaxy. And if you have any questions for any of those plug-in infrastructures or how that works, please drop me a mail and I can give you more information about that. Galaxy as a framework is completely agnostic to any community. It really just, is about these abstraction layers, and different communities can then hook onto this platform, integrate tools, integrate visualizations to actually satisfy the community needs. Talking here about the European perspective, together with the Elixir research infrastructure, we have actually worked with a bunch of different communities across different domains to spin up kind of different Galaxy flavors with different composition of tools. So you see here that it's, of course, heavily driven by life science. And this goes then from drug design, so cheminformatics to metabolomics, imaging analysis, but also then single cell, virology, and so on. But there are also Galaxy flavors about climate science, material science. We have now a very recent one about astrophysics. All these communities can use or are demonstrating that Galaxy is actually capable to be used beyond life science. Let's talk a little bit about research data management, and this is a classical research data management lifecycle, which Galaxy tries to really have solutions for all of these stages. If we talk about data import and data access, as I mentioned, we support the GA4GH standards, but we have also integrations, and again, this is just a plug-in infrastructure with different data providers like Uniprot, Intermine. We have Omero adapters if you want to import images, UCSC for the genome browser, NCBI. So these classical data providers are just a plug-in in Galaxy so that Galaxy users can really from Galaxy import data compute and start workflows or tools on top of them. Because Galaxy is driven by this rich API, we have seen various LIMS integrations in Galaxy that then can also be deployed to users. The next step or the next steps, this data transformation, Galaxy comes with a lot of different tools for doing data transformation and data to convert from different file types, for example. But we also provide more sophisticated interactive solutions like, Jupyter Notebooks, RStudio, if you know OpenRefine. All these are interactive tools, so we call them interactive tools. They are running in their own server, and a user can just get their own Jupyter Notebook or their own OpenRefine platform to clean up their data or to do data processing. But we also provide a bunch of different domain-specific tools for genomics, for material science, as I already mentioned. And this is then really done by the community to keep that set of tools growing. If you have done your analysis and if you have computed your research, you probably want to export data, right? Or preserve the research artifact that you actually have created. So there are different other plugin infrastructures so that you can actually now export your research artifact to an S3 bucket, to FTP server, or to your Google Cloud Storage. We offer a few file types that we can that we can create for export. So for example, we are now supporting the research object crate or biocompute objects. So whatever you do in Galaxy, you can then export your complete data analysis as research object and dump that, for example, in your Amazon bucket, or as you will see later, also to Zenodo or to Invenio. And the same goes for workflows and other artifacts that you create in Galaxy, like complete histories and datasets. The sharing aspect is really fundamental built into the Galaxy platform. So you can share everything in Galaxy with a specific person, but also with a group, with the entire, it's a role-based access model, like the Unix system, but you can also share that with the entire world, and then you get a public link and everyone can then see your workflow, can see your data analysis, import it in their own workspace, and then change the workflow, for example, and run it on their own data. So all this sharing is pretty much built into the framework and actually is true for visualizations, datasets, workflows, workflow reports, workflow invocations, and much more. And then reuse. For example, we can export those artifacts, as I already said, and then people can re-import them again. So there is a collaboration with Workflow Hub, with Doc Store, so that you can export workflows, but you can also, and other users can then import them. But we also put a lot of effort about how do we actually manage storage for our users, or how users can actually manage the storage and reuse these artifacts as much as possible. So just briefly, because everyone was talking or will talk about workflows, just a few brief things. So in Galaxy, a workflow is not only like what you are seeing here, but we also have, we try to guide users to actually create high quality workflows. And this we do with a best practice kind of wizard thing, where we really try to say, okay, please add a license. Yeah, and then you get SPDX identifiers. We encourage users to add a license, to annotate the creator, to add a lot of different annotations to a workflow. And you will see here what is missing to create high quality workflows that then can be stored in Docstore or Workflow Hub. Another aspect is this integration then with those workflow registries. So you have on the right side, you have the choice of, if you are on Docstore or Workflow Hub and you're searching for workflows, you have this button where you can then directly start or execute a workflow on those infrastructures, like the Australian or the European Galaxy server. But on the left side, you have kind of the screenshot from a Galaxy server, where you then can say, okay, I want to search on Workflow Hub for a given set of workflows. You will then see here the workflow list, and you can just click on them and run them in your own workspace. So all this integration with a workflow registry is also TRS based, which is also a GA4GH standard. Workflows could be also considered as asynchronous workflows. So this is what you usually do when you use Jupyter Notebooks or RStudio instances. And RStudio and Jupyter Notebooks are just normal Galaxy tools. So you can actually use Jupyter Notebooks in classical HPC workflows. We call that then person in the middle. So you can really now mix classical HPC workflows with more interactive data analysis steps in Jupyter Notebooks or RStudio. And there are much more of those interactive environments. RStudio and Jupyter Notebook are probably the most common ones. But just imagine you have also then something like a spreadsheet application like EtherCalc, or entire virtual desktops that you can start if you are in earth science and you know Panoply from the climate science. Those are really dedicated interactive environments for specific tutorials. And if you want to check them out, we have also a lot of different training materials to all these different aspects on our training platform. Okay, the last part of the talk I would like to dedicate a bit about and talk about storage, because storage is really always a bottleneck. So if you deploy a Galaxy server, it's not compute that is limited, so it's usually the storage that is limited. And storage always goes up, right? So what we are currently doing on these public Galaxy servers is we are offering 250 gigabyte quota for every user that registers. There's a request form to get temporary more storage, but 250 gigabyte is what every user gets. On the European Galaxy server, we are now using 3 petabyte of storage for our users. And to be honest, I mean, we rely on Moore's law, right? We need to buy new storage every few years. We need to replace the old storage. And essentially, the users on the European Galaxy servers are really kind of dependent on us writing grants to get these infrastructure in place. So this is obviously not a scalable solution. So we have developed over the last years solutions for more federated infrastructures. And this goes into various domains. For example, in Europe, there are now 7 national Galaxy instances, so people can use more dedicated national funded infrastructures. But there's also a federated compute network, for example, so that one Galaxy instance can submit jobs across the world and compute in other compute infrastructures. And the same we are now doing for federating actually storage. And this is what I would like to talk with you in the next minutes. So what options do we have to actually deal with more storage demands? One solution is to not import any data into Galaxy, right? So for example, raw data doesn't need to be actually put in the user space. We can just download the raw data to the compute infrastructure wherever we run the job, and only the result is then put into the Galaxy storage. But the raw data does not need to be stored permanently on the Galaxy storage. So that's one solution. We call that deferred data import or deferred data sets. Yeah, let me know if you want to know more about that. It's a quite neat implementation, I think. We can also talk about additional scratch space for users. So this is a solution where we offer maybe even more storage for users, but this storage is clearly indicated that it will be removed after a month. So every data on this particular scratch storage that is older than a month will be removed. This will also help a lot already with our storage demands. Another thing is that data needs to leave Galaxy as soon as possible, right? So by enhancing our export possibilities and working actually together with long-term archives, this could be a solution to encourage users to create research objects as soon as possible and export them as soon as possible. Another solution is really to diversifying the storage options that we have, so that a user actually can bring in its own storage capabilities. So let's assume you have a commercial storage on Amazon or on Google Cloud, and you want to bring it to a public Galaxy server, right? So can we enable that users can actually bring their own storage, what we call user-based object store, or bring your own storage? And this is what I want to show you now. This is now in the Galaxy framework integrated. So a user can choose between different storage options. From the dashboard, you can run different workflows against different storage entities. So let's say you are currently developing a workflow, you want to run it only against the experimental Scratch storage. That is a very cheap storage. But yeah, it's not backup and maybe you lose data. But as long as you develop your workflow, this probably isn't much of a concern. But if you actually want to run it in production kind of, or if you want to actually persist your data for publication, you want to probably then run it against a second-tier storage or a high-performance storage. And this can be configured by a Galaxy administrator nowadays. And we can also nowadays enable a user to do that. So a user can now go to their user preferences and select one of the template object stores that an administrator provides you. You then click on one of these options here. You fill in your S3 credentials or your OneData credentials or your iROD credentials. And then you have a different object store as seen here, just with your personal storage. And Galaxy will then make sure that all the data that you generate is put on this storage. Here you can see how then this looks like. So you could have multiple storage configured on your user account, yeah, in your account. And all these different storages can have different descriptions and different symbols. And I will talk about these symbols later on because this is an important aspect. Here we are already, sorry. So one thing is that storage is of course complicated. And if I talk here, for example, about, oh, this is experimental Scratch and it's not backed, but it's maybe fast or slow storage. Is it secure? What does it mean that it's secure? Right? These are all quite complex concepts for users. And what we have is we have a visual language to indicate that. Yeah, so we have an indication if it's fast storage or slow storage. If it's a short-term storage, means that we delete or purge data after a given time. We will also indicate if it's backed or if it's secure. For example, you can have really a private object store where you disable all sharing capabilities that Galaxy offers you on a very low-level implementation level, on the object store level in Galaxy, so that people not by accident share sensitive data with others. And this we can indicate with those symbols to actually communicate better to users what such an object store is like. And talking about communication, I think that's an important aspect that in Galaxy we actually offer a storage dashboard and also notification where we indicate users how to move data from different object stores, which object stores actually full, how to move data, how to clean data, right? How do you find in 250 gigabyte of data, potential data that you can clean? Yeah, so all trimming data and so on that you might want to clean and free data can be now implemented in such a storage dashboard. And then users can really, as you on your desktop look over your storage options, clean data and free some storage. The notification infrastructure that we added in Galaxy will now also leave a lot of flexibility to the Galaxy administrators to indicate, for example, that a new storage option is available or that you are over quota and give you certain hints as you go. Last but not least, exporting data, right? So if people have finished their analyzers and have, if a workflow is finished and you want to now publish it, it would be nice if data can leave those compute and storage infrastructures as soon as possible. So what we integrate is a very flexible, again, a plug-in system exporting framework. So you can now take a history or an entire workflow invocation, a workflow run, and export it to any given storage that you have attached. Now this can be as I said, a Dropbox account, a Google Drive account, but also simply an FTP directory from a university and so on. We do support these research object crates. So this is kind of our file format that we really would like to endorse to ship between different systems. And row crates contain all the provenance information that we have for a workflow. So which tools have been used in a workflow, with which parameters, how to cite those tools, which file formats goes in and out. So this is all really encapsulated in such a row crate, and we can export that. Another aspect is that we also can export this to permanent archives like Invenio or the Invenio deployment Zenodo. So you can choose in Galaxy nowadays, I want to export my entire workflow run to Zenodo. And you get then a document identifier, which then is captured in Galaxy. So data is now has left Galaxy, but you still have the which you see here on the right side. You still have the track record in Galaxy when this history or when this workflow was exported, if it has been changed since then. And you can always go back and import the data again from your document identifier from Zenodo when you want to work further on it. So we really want to make it very easy to export all your data provenance of your data analysis to a permanent archives, but on the same end, make it very, very easy to re-import it again for the same users, but also for others users that really want to see how this analysis was being done, mess around with the data and so on in a reproducible and very transparent way. Yeah, and that's it. Thanks for listening. I just want to mention that what I just said for user-based object store is also possible already on a computational base. So this is a federated compute network that we have deployed in Australia, in North America, and in Europe. So Galaxy is already able to submit jobs to different computational resources across the world. And now, with the latest developments, we can also do that with storage. And of course, we can combine both, right? We can then say, if the storage is in Great Britain, please use compute that is in Great Britain and optimize our job scheduling in that way. Another thing that I just want to mention, please let me know if you want to know more about how this entire framework is used for training, or check out the training.galaxyproject.org website for more than, I think we have hit now the 400 different tutorials about different scientific domains. Thanks for listening, and thanks to the entire Galaxy community to make all that happen. Yeah, if you have questions, let me know.
Excellent. Thank you, Björn. I had I guess, a comment. And as you know, I mean, here in Australia, we are on our Galaxy server, we are always looking at the storage of the data. I think that's a really interesting, an interesting challenge to think about. I really like how, you discussed all these, I guess, encouragements to get, for people to get the data off. But does it all really, though, come down to policy? Because, you obviously need to have the infrastructure set up so people can move their data off, but unless they're maybe, encouraged actively or required to move the data off, will people ever move it off? I mean, I'm just interested in your thoughts around that.
I mean, the point is that we have these quota, right? So if people actually want to analyze new data, they need to move off the infrastructure, right? They need to free data, or they need to free the quota to actually, analyze new data sets. And I guess if we offer them a bunch of options how to move data and make that actually very, very easy, right? So that it's not that you don't need to spend a week to actually store your data somewhere in a let's say, fair way. I think then we have the carrot, right, to really encourage people and to do the proper thing and to, do fair data management in a proper way. What we are doing in Europe, or very concrete here in Germany, is that the universities on its own will have permanent storage. So they will have an Invenio instance or something very similar to Invenio to actually offer storage for their own researchers. And Galaxy, with this new framework where you can plug in those Invenio instances very easily on a per user account, right, would make it very easy to store data at your own university. And I hope this is encouragement enough also then from your local university that this feature is hopefully used together with the quota requirements, of course.
Yeah, great. Thank you. All right, I think we need to move on. Time keeps on ticking. Thanks again, Björn. Questions for Björn into the chat. Now I'm going to share my screen and we're going to next hear from Rob, who is going to talk to a topic probably more related back to TACUs. So let me just start this up and over to you, Rob.
Yeah, thank you. So indeed, I am talking about an infrastructure we're building in Europe for sharing human genetic data. So indeed, very much like the infrastructure in Africa, maybe not as far along as you are in Africa. So the 1+MG initiative, as it's called, 1+ for more than 1 million genomes. It was an initiative, I think, the original person who started with it already started talking about it in 2016, and he talked to a lot of different government representatives to say, well, you know, I have this ambition. It would be great if we would have for European research 1 million European human genomes available for research, healthcare, and health policy making. And in the beginning of 2018, he got 13 signatures, and quickly that number has been growing. Even at the end of 2018, the Netherlands already added to that list, and since then it has been signed by 27 countries in total. So this is an initiative originally called the Million European Genomes Alliance. And now, of course, the plus signifies that the million is really the start and we want to get more. We just heard Björn talking about 3 petabytes of data, just to give a little bit of an idea. If we are selecting 1 million genomes, then we're talking about INCRAM files, maybe 65 petabytes of raw data. Serious amounts, and we definitely don't want people to be allowed to share or download any of that data. There are very strict security concerns, very strict European privacy laws, and so there is a need for rules and for ideas on how this infrastructure can actually be made useful, and that's where the framework comes in. So on the next slide, you'll see the timeline. There is really a journey from this moment in 2016. No, here it says 2018 because that was when the first signatures were placed, towards now at the moment already past 2027, when we really want to have an information infrastructure online. So the initiative was signed in 2018. Since then, people from different European governments are coming together every few months in Brussels, talking about how to get that realized. In around 2021, we got the B1MG project, Beyond 1 Million Genome project, which was a European funded project that brought people together to talk and think about how this dream actually can be realized. At the end of 2022, we started the European Genomic Data Infrastructure Project, the GDI project. that is currently active and where I am located, that is actually realizing the infrastructure. It's trying to build it. So we see that in Europe, we went from a design and testing, just a proof of concept. Can we actually do something towards a scale up and sustainability? So there is no development. It's a really interesting part. Also, the different countries that are in the projects are really at different stages. If I compare, for instance, Denmark, who have been already for years working on a national genome center and have their national infrastructure, and compare that with the Netherlands, where I am. In the Netherlands, we are just building a health data infrastructure. So we really want to have a genomic infrastructure as well, but there is definitely not a government plan to make a genomic infrastructure. So that's, we are building it in the context of our national health data infrastructure. The purpose of the whole infrastructure set of projects here in Europe is to bring this all together, do it in the same way. And of course, we are helped there with European rules and regulations, the European law that is trying to not only for goods and people, but also remove the borders for data. Now, that is an interesting challenge here. So many people will know probably the GDPR law, the European privacy laws, which are often used to say to people, you can't share data, but actually that were meant to share data within the European Union. It's actually supposed to be more. So what is happening here is that there are many different projects. I haven't even talked about the population genomics project, which we are anticipating starting, which is meant to fill up the data infrastructure with at least 500,000 genomes that are representative of the European population, so that it's not only people that have come to hospital to be sequenced, but actually is a representative, that the data that is available is actually representative. So this whole thing, there are several different European projects and an initiative that need to share information. And on the next slide, you see that this is that there is a framework of information being built. So all of the conclusions that are being drawn in the project are being documented in this 1 million genomes framework to document which standards we are using, what explorations have been taking place, what things have been tried, and how we are actually building this infrastructure. So in the project, we really want to, for instance, keep the localization, the locality of the data the same. That's one of the things that has been said to satisfy laws, but also practical aspects of moving data. We do not want to move the data around, but that has consequences for things like who's going to pay for the infrastructure, who is running the infrastructure, and that means that there needs to be billing probably. And these kinds of things still need to be worked out and made. And every time something is worked out, the purpose is that this will be added to this 1+ million genomes framework, and this can be used also by others. So it's supposed to be experience from this European framework combined with the standards, for instance, from the GA4GH to build this. The idea really is, so there is technical infrastructure there. The technical infrastructure is defined based on the interfaces. Every country, because they are so different, is using different tools to actually realize these interfaces. We're making appointments on how to interoperate between these interfaces. So we will be talking about, for instance, TESS and WES to run the workflows over the different countries. So everybody will need to provide those interfaces, but whether that is provided by a commercial cloud or by an on-premise interface, an on-premise resource, that doesn't matter. That is the decision of the country to do it. And we just make appointments about the minimal specifications, for instance, security specifications that need to be held up. The central idea of this whole infrastructure is the catalog. So we will be using data that is classified in data sets, and those data sets will be described as other data resources in Europe using the data catalog ontology, DCAT, to actually describe the data and to actually be able to locate it. And then there will also be a central resource to request those data. So all of those interfaces from the beginning, from how to get data into the resource until how to reuse it, they are specified in this 1+million genomes framework. There is an example page on the next slide. So there you can see how these kind of things are documented, with the different aspects being recommended or required indicated, and you recognize some of the standards from GA4GH there. So the last slide already. So it is really meant as a global reference point. We really hope that we are not only doing this for Europe, but that interoperability is served if other infrastructures in other continents or other jurisdictions would be using similar developments and similar standards, and that's why we're documenting it here. It was made as reusable as possible. Of course, there are some European laws that are being observed here, but I think there are lots of compatibilities there as well. So that's approximately it.
Thanks, Rob. I think we're going to move on. We are rapidly running out of time, so let's go over now to Sverning, who is going to speak to us around something that actually brings the two themes together quite nicely. Running sensitive workflows on public Galaxy servers. Over to you, Sverning.
Thank you. You can hear me?
Yep, perfect.
Okay. So let me just get this out of the way here. Yeah. Okay. So this is a talk that's called the actual current name of a project that we are trying to get funded right now. Empowering users, orchestrating sensitive data access for interactive federated analysis in virtual research environments. And these are the current members of the consortia. So I'm going to do things a bit untraditionally here and have a bit of a tongue-in-cheek presentation. So I'm not sure if all of this will support that. So this is my presentation, but the content is at least supported by all these people. So another word name for this presentation would be a tourist's guide to supporting analysis of sensitive data. And starting with a disclaimer here. So this is a tourist guide. This reflects the fact that I'm relatively new to the field. So I might invent my own terms, misuse terms, or misrepresent standards and concepts in a way that might be confusing and or insulting. But I am an experienced designer and developer of systems, so trust me when I talk technology, but question my knowledge elsewhere. Okay, so what are the main issues that one typically wants to solve in an analysis solution for sensitive data? Okay, so first of all, as many people have been talking about here, you would need to align with policy and regulations. Unfortunately, before you do that, you need to know and understand them, and I don't really do that. So let's drop that point. I'm not going to focus on that. But the next step, which I do know a bit about, is the trust issue. So you will need to trust the chain of trust. Basically, is the user who she or they claims to be. Can I trust the entity that verifies the user's claim of identity? And can I trust the entity that trusts the entities? Basically, who watches the watchmen? That is a fundamental problem underlying all of this. And the next thing you need to do is to delegate access to data without making everyone miserable. So you need to make sure that only authorized individuals, data storage, and or compute solutions can access the data. And you would try not to create a Kafkaesque labyrinth of bureaucracy while doing this. Fourth step is to enable the correct geolocation of data. Make sure that the data does not go outside the country boundaries if that's requested, in accordance with point 1, which I unfortunately deleted. Okay. And then you would need to secure the data in situ, in statu, and in motu. Just adding a bit of Latin in here, and actually ChatGPT helped me with this. So you want to ensure that data is not compromised to unauthorized individuals in its original location, at rest, or in motion, including during analysis. And you would need to orchestrate a distributed and/or federated data symphony, unveil thematic data in due time and place, arrange all kinds of instruments and transcripts, both musical and genomic, and let the analysis resonate close to the data. And lastly, you would want to provide an accessible and intuitive user-controlled analysis experience. How many of these points are there, really? Perhaps we should also list the last point, at least for the sake of symmetry. At least that is what users might typically experience. Okay, so once you have tried to manage all of these solutions, what do you do, or where do you start, basically? Well, you start with adding, stamping this with GA40H standards. So actually they have a lot of policy-related standards. They can, in the terms of trusting, you have AI and passports. In terms of the delegation, you have passports and actually something called DACRES, which I discovered just now, which manages the bureaucracy part here. They don't actually have a standard for the correct geolocation of data as such. They sort of, all the other standards enable that. So I just wanted to stamp this with something. So here's a Costa Rica stamp, visa stamp. Hopefully I will be able to go there this autumn. And this is the license. Okay, so important here, this is where I'm aiming towards here. So security, secure the data in situ, in statu, in motu. Crypt4H is a standard which is a bit under communicated, I think. But basically this is a way to secure the data everywhere. Orchestrating, DERS, TESS, WES, this has also been talked about. And there's no standard actually for the user experience. So that's not so important, perhaps. Oh, let's see. Okay, so you have all of these different stamps. I'm going to focus on one of them, which is the Crypt4H one. And basically what we have found out in this project is that we can use the same mechanism and really support all the other core aspects here. So trust, even trust, that's a bit perhaps out of scope, but you can actually do that in some level. The delegation of data, that can actually be done through cryptographic means with Crypt4H. The geolocation of data can be supported by Crypt4H. Orchestration of this symphony can be supported, and you can also use Crypt4H to provide an accessible, intuitive, user-controlled experience. And you can use it for policy. No, you cannot actually. But all of the others you can, in some sense, use Crypt4H to underpin. And I'm not saying that you should replace all the other standards here, but you can secure them. It works on a different level, basically. So how did we do this? So first, just very basic, what Crypt4H supports here. So basically, Crypt4H is divided into two things. You have a header part and a dataset part. The key for dataset part goes into the header, and then you doubly encrypt that one. I see I'm running out of time here. So a underappreciated feature is of the standard is something called header re-encryption or re-encryption. So this is illustrated here in the context of the federated EGA. So basically, if a user provides a public and private key pair, you can then re-encrypt the header part for that user, make sure that the user is the only person that can get access to that without touching the data sets. So this is the basis of a previous work that we did in the context of an Elixir implementation study called Strengthened Data Management in Galaxy. So there's some links here to learn more about this. This is the concept that developed, so I do not have time to go through all of that. But basically, we're using this encryption for making sure that Galaxy can provide encrypted or analysis of encrypted data. So we made a prototype of encryption on the user side, importantly, without sharing the private key, but it still requires this trusted exchange of public keys with the compute. So very briefly, how we want to extend this. So we want to move this into an end-to-end production-near implementation in Galaxy, where we want to prioritize the user experience here. And importantly, the Crypt for Edge solution allows the user to be in control of the delegation of data access, saying that this computer source is allowed to decrypt the data and using re-encryption as the basis of this. You need this re-encryptor service, which we have the prototype of, running both on user and compute. And we also want to expand this with trusted management and sharing of keys. And as Björn mentioned, there's this feature in Galaxy called deferred dataset, which we believe can actually support the decoupling of data. So typically in Galaxy you have central storage, but we would like to eliminate that step and make sure that data can be manifested directly into a compute node, into a trusted research environment, for instance, without this middle step. And Crypt for Edge re-encryption would, in theory, allow that. We want to try to make that into actual implementation and allow a normal interactive user experience in Galaxy. So that was all I had. These are the groups supporting this work.
Thanks, Svenning. We're going to have to move straight on to Rory's talk now. We've only got a few minutes left. We'll probably go a couple of minutes over, but I would like Rory, please feel free to speak for the full 5 minutes, and then we'll wrap up after that. So I'll share the screen for you, Rory.
Okay, hi everyone. So this is going to bring in another perspective. Most of the talks today, I think all of the talks today have been about life sciences specific infrastructure, and my talk brings out the point that there are two important forms of generalist research infrastructure which are quite rapidly emerging around the globe, and both of these types of infrastructure are already thinking about, but need to think more about how to interface effectively with domain-specific infrastructure, like the kinds of infrastructure that we've been hearing about today. So next slide, please. So, and I specifically, my talk is focused on interoperability in research infrastructures generally. And I just put up, for those who aren't aware, the Global Open Research Commons model, which was produced by intensive work from an RDA group last year, and is now the inspiration for a number of global open research commons, which are, as I say, springing up around the world. And the two particular types of interoperability that I'm going to talk about are also resonate with other things that people have said today, which is the interaction between storage and compute and research tools, and also interoperability between research tools. That came up quite a bit in the Galaxy talk. Next slide, please. So there's actually three examples that I'm going to mention. One is the research commons, and the other two are research clouds. And I think the terminology is important. So the research commons, this proposed Norwegian research commons, which is the first commons to be explicitly developed in really in excruciating detail, building on using the Gork model as its inspiration and really as its design instructions. And you can see here the classic research lifecycle, or an instantiation of the research lifecycle. I don't know how well you can see it, but there are a bunch of generalist tools here, which are deployed at various stages of the lifecycle, and some of them are already interoperable. But a lot of the work that's proposed for building this commons is to enhance tool interoperability to achieve the two things which Jeff mentioned at the very beginning, which are easy passages of data throughout tools used in different aspects of the research lifecycle, and importantly, also continued association of metadata that's associated with those tools throughout the research lifecycle. So I think the interoperability here is actually, it was a core feature, and it's certainly acknowledged as an important thing. What's less well developed here is so that's the interoperability between the tools, is the interoperability with storage. You can see Irons is kind of the device or the mechanism that's designed to reach interoperability. But I think one of the issues here is also, it's also what should I say, a human or organizational issue. So do the people that provide the storage, are they prepared to collaborate with the people that develop commons and provide tools? Well, that's an open question. So interoperability depends on the willingness to collaborate, as well as technical issues around interoperability. So the second kind of beast which is coming in, which calls itself is Research Cloud. And the New England Research Cloud is I think a very interesting example, because it's bottom up. Most of the stuff that's going on is actually top down. But the New England Research Cloud is the creature of Harvard, MIT, Northeastern University of Massachusetts, and Boston University. So 5 universities in New England. And they, again, the cloud versus commons, the commons, when you see commons, people are probably coming at it from a research data management perspective. When you see cloud, it's coming from an HPC and compute perspective. So the people behind this are the people in research computing and HPC. But nevertheless, what they are proposing is actually quite similar. You've got a data center, you've got a cloud layer, and then you've got a series of services. This is a much less developed set of services, but they're beginning to see the need for a series of generalist research services which sit on top of the cloud. And then the third one, which is not on the slide, but which is also interesting, is Canada's Alliance, which is their national research body. It's called the Alliance Cloud Connect, which is, again, similar to the Research Cloud, the Research Cloud, because it's compute and store and HPC based. And interestingly, the two, they have a call out to layer on top of this a series of what they call researcher-facing services. And interestingly, the two which they already focused on are Jupyter Notebooks and Galaxy. But they too are now seeing the need to also include more generalist tools like data repositories and research data management systems like Dataverse and RSpace. So implicit in all of these generalist infrastructures is another kind of interoperability, which is interoperability with domain-specific existing and future domain-specific resources, tools, infrastructures like Galaxy, for example. And I think that's just an open question, but I think it's an important question. And I think these new generalist commons and generalist clouds need to really think about how to collaborate effectively with these kind of domain-specific infrastructures. And that's a complicated issue itself. As we saw, the storage issue, even for storage is an aspect of Galaxy. So there's some interesting challenges there, but I think there's some interesting opportunities as well. Thank you.
Thanks, Rory. That was excellent. A very great to see a perspective from I guess a more generic one, not from the life sciences, but the challenge is actually universal. I think what we're trying to address. Okay, we are over time. Apologies for that. So there's two approaches I think we are going to do. So Volmar, did you want to talk to these?
Sure. So we would like to explore venues for continued collaborations and discussions on this within the RDA specifically, but also with groups outside of the RDA. We could probably stay a few minutes after this, but since people will have other things in their schedules, we are not expecting that. And we have this exit poll that I shared in the chat that you can use to fill in some ideas on groups that we should reach out to. Or actions that you're planning to take following this session. And then we could help you bring together either connections to the speakers from this session and the before session last week. And we also propose perhaps having a post-plenary discussion at some point where we would distribute an invitation to a meeting either later this week or sometime early next week. So for those who would be keen to join and would have time in their schedule, then there will probably be an opportunity going forward as well. But maybe if anyone has any ideas of obvious opportunities or things that you think that are crystal clear that we really should start to pick up on right now during the plenary, please feel free to kind of speak out and share. Particularly if you're engaged in an RDA group where you think that there are some connections that we should try to capitalize on now that we're here in the plenary and have Whova accessible.
Well, I think the two groups that I'm involved in would be relevant. One is the GORC, which is continuing, which of course, Volmar, you're also involved in. And the other is the mapping the landscape of digital research tools, which is a working group which has just wrapped up its or is just wrapping up our year-long project, and we're have produced a map of mostly generalist research tools which are used at different phases of the research data lifecycle, categories of tools, and then examples of tools. And I think again, this is also the need to engage with the life sciences community is important as well. So those are two. I have some other ideas beyond RDA, but those are two RDA groups which I think would benefit from interaction with this group.
Perfect. Thank you, Rory. Anyone else has any ideas?
I think if people want to write anything into the collaborative notes, please do. The link is in the chat. And as I said, you can also put some ideas into the Menti poll. If you put your name and your email address, we will follow up around the potential follow-up session next week or some other time. Maybe have a conversation over email as well, which may work better for the time. So I think we will probably need to wrap it up there. We're a little bit over time. So I'd like to thank all the speakers again for presenting today. They were really great talks. I'd also like to thank the presenters from the former session and all of the attendees for coming along today. So thanks, everyone, and hope to see you online soon. Bye.
Thank you all.
Thanks. Thank you.
Bye, everyone.